Thermodynamics. My name is Jitendra. My topic is about influence of electronics and ion thermodynamics on the magnetic nozzle plasma expansion. Introduction. And magnetic nozzle is an applied convergent divergent magnetic field capable of guiding the expansions of an energetic plasma jet and accelerating it supersonic into vacuum. The contactless operation of MNS avoids the determinantal durability and efficiency issue associated to plasma wall interactions and provides a super control over the expansion. The qualities make them an interesting device to produce thrust in space. Currently, several advanced plasma thrusters, including the helicon plasma thruster, the electron cyclotron resonance thruster, the applied field magnetic plasma dynamic thruster, and the VISMR 9 employ AMN as their main acceleration stage. In a MN, the internal energy of plasma is transformed into direct kinetic energy, much like in the case of neutral gas in a traditional solid D-lava nozzle. Therefore, all plasma thrusters operating on MN are in essence thermal rockets. This means the specific impulse is roughly proportional to the square root of the temperature to which the plasma is heated inside the plasma source over the ion mass, that is ISP, that inversely proportional to PT by MI, requiring very large temperature to achieve competitive ISP with a usual propellant like argon or xenon, not withstanding MNS, and the plasma thruster relying on them constitutive an attractive propulsive technology thanks to their higher thrust to power ratio, simplicity, robustness, versatility, and presumed long useful life, in contrast to solid nozzle which has a physical wall on where the propellant exerts a pressure force to produce thrust. The more complex physics of plasma flowing in MN give rise to variety of acceleration mechanism not present in a solid nozzle, which nozzle one azimuthal dynamic and electric current in plasma and magnetic force, the development of an ambipolar electric field that transforms electron energy into ion energy, the possible formation of electric double layer within plasma flow. Extended plasma MN model, a full derivation of axisymmetric to fluid plasma MN model can be found in refer 20. Hence here only summary is given to facilitate the comprehension of the rest of paper, and focus is placed on the extension to include electron and ion thermodynamic. The plasma is assumed collision less, quasi neutral, and global current free. Electrons have negligible inertia and fully magnetized, meaning the electron stream tubes and magnetic stream tubes, whereas ion can have any magnetization degree. In this first step toward modeling the evolution of distribution functions as a rough approximation, both spaces are considered isotropic and Maxwellian under the assumptions the plasma responds to following through this equation. n ui is equal to 0 delta n ue is equal to 0 mi into ui dot delta ui is equal to minus delta n ti by n minus e delta pi plus eu into b, where most symbols are conventional and one is perpendicular unit vector perpendicular to the magnetic field. In the following induced magnetic field, the plasma generates in neglected, assuming a low plasma beta, although it can be included easily with an iterative approach, keeping only the applied magnetic field with satisfy gamma b is equal to delta u into 1 theta with u the magnetic stream function. Next we need a model for TE. In this case of electrons we will assume that they follow polytropic expansion. TE is equal to CE n to the power of gamma e to the power of -1 along each magnetic line where gamma e is an effective specific heat ratio exponent and CE is equal to TE into 0 comma r by n into 0 comma r into gamma e minus 1, a constant defined by the upstream condition of that line. Observe that due to the lack of collisions and strong magnetizations of electrons, CE is in the principle different for each magnetic line. CE is equal to CE U ions. On the other hand, only marginally magnetized in the envisaged application. This means the cross field thermal mixing takes place more easily for ions than for electrons, suggesting the choice of a simply polytropic model for the whole population. Ti is equal to Ci n to the power of gamma I power -1. With Ci Ti 0 by n 0 to the power of gamma -1 give the values at origin coordinates. The above model for electrons and ions allow for a convenient mathematical implications of equation. First note that an ion barotropic function exists. Hi is equal to gamma I by gamma I to the -1 into Ti. That satisfy Dhi is equal to D into Nti by N, or in the isothermal limit gamma is equal to 1. The combining both equations eliminate the electric field. The equation for ion becomes Mi into Ui into delta into Ui is equal to minus delta N into Te plus N into Ti by N plus Eui into B minus Eu theta E B1. Perpendicularly it is used so that the equation is analogous to the momentum equation for cold ions. When the total temperature T is equal to Te plus Ti is used, multiplying the equation by Ui and integrating yield the ion energy equation by Ui and integrating yields the ion energy equation Mi into Ui square by 2 plus integration D into N into Te plus N into Ti by N is equal to Mi Ui square by 2 plus E pi plus Hi is equal to Hi Ui, where Hi is constant. So the ion stream tube labeled by I examinations of expressions shows the effective ion sound velocity is given. The equation for constant Cs square is equal to gamma E Te plus gamma I Ti by M. Effect of electron cooling condenses the effect of electron stream length thermodynamic on the behavior of ambipolar electrical potential U, from where various aspects can be already inferred to focus the discussions on effect of electrons cooling in these sections. Two simulations with plasma conditions n into 0 comma r is equal to 0 n0 c into c r 0 comma r is equal to 0 comma r is equal to 0 u theta I into 0 comma r is equal to 0 ci is equal to 0 will be used with two different values gamma e 1.2 and 1. The Mn geometry is given by a single current loop located at z is equal to 0, r is equal to 3.5 capital R, where capital R is the radius of plasma jet at the throat and magnitude and of the magnetic field is fixed EBR by root over MITE. 0 is equal to 0.1. First, as plot in a figure, and the polytropic cooling law consider here reproduces the extensions of an asymptotic value of potential on each magnitude tubes. The equation E pi is tends to E pi infinity is equal to minus gamma E by gamma E minus 1 T E 0 as n into T E tends to 0. With T E 0, the value at throat such a bounded potential is an expected feature of the expansion. In contrast to unphysical behavior is an isothermal mode where it continues to decrease logarithmically infinity. The below graph represents the ambipolar electric potential as a function of plasma density n for different values gamma e. As expected, the ion Mach number M increases at faster rate than in isothermal plasma since Cs is proportional to root over Te. Higher Mach number is more marked at plasma edge where the isothermal plasma reaches only half that value. It construct Ui proportional to root minus U is lower when plasma cooling takes place than in isothermal model. Interestingly, the difference in velocity magnitude between jet edge axis is also reduced, and in the present simulation where infinity is small for magnetic lines must asymptotically vanish. The lower divergence ion streamline can be observed in compared to the gamma E is equal to 1. It is a constant pressure case. Increased inward ion separation from magnetic streamlines led to a larger radial density gradient and an enhanced plume divergence efficiency. New plume defined as the ratio of axial total kinetic energy at a given z constant section. This graph shows the m into r is equal to rb at z at the point 0 and it raises to 8. It shows the r m into r is equal to rb value at point 0 and raises to 4. It shows the m into r is equal to 0. 0 this is the z by r graph. In relation to plasma, cooling facilitates plasma detachment. To justify the statements, observe that ion detachment from Mn is guaranteed as soon as they become unmagnetized and hypersonic. 34 Since magnetic electric and pressure from on them decreases while their inertia increases, meaning then eventually no further outward deflections can occur and their trajectories which approaches a straight line. That is the most ion do not turn around even if electrons remains magnetized. As ion carry the plasma mass flow, their detachment ensure the ejections of propellant mass as required for propulsion. The down graph shows that the plasma density background map, and right side graph shows that plume divergence efficiency. New plume is equal to pi z by pi, where the ratios of axial to the total ion power for Re is equal to 1.2. Lastly, the existence of an asymptotic value of the electric potential help to find a clean closure for the energy balance in the plasma plume. In essence, electron cooling at different rather than adiabatic one. Gamma is equal to 5 by 3 is sustained by an electron flux QE coming from the plasma source that keeps up the electrons temperature up as they expand. That is, the electrons cool down as Te is proportional to n gamma E minus 1. Instead of cooling down as Te is proportional n 2 by 3, the excess power needed to replenish their internal energy is provided minus dou QE by dou 1 K. Assuming that plasma completes the expansions within the region validity model at that QE is equal to 0. We can estimate QE Q mod E at the Mn throat from the energy equations. P beam is equal to Mi ui square 0 by 2 plus 5 by 2 te 0 mi plus qe 0 is equal to mi ui square 0 2 by 2 plus gamma e te 0 by mi by gamma e minus 1. QE and Z is integrated electrons heat flux at section Z. This equation provides the total power flowing, that the total electrons heat energy at throat. It's giving derives the equation QE 0 is equal to 3 by 2 mi TE 0 mi into 5 by 3 minus gamma E by gamma minus 1. Influence of thermal energy. Both ion and electron thermal energies can be transferred into direct axial in ion energy in Mn. In essence, the perpendicular energy each charge changed particle converted into parallel energy thanks to inverse magnetic effect. Notwithstanding the microscopic role of each species, thermal energy is different. Electrons thermal energy on the one hand causes electron to expand to create an ambidextrous electric field, pulls ion downstream. In this way, electrical field minus delta acts intermediately for the plasma energy. This figure represents this graph represents the fraction of total ions in energy gains. These three graphs represents electrical potential for Ti 0 by Te 0 is equal to 0, 1 and 2 for an initially non-uniform plasma jet. The electrical potential has been normalized with the total temperature. T is equal to Te plus Ti. Solid lines represent isopotential surface in the plasma spaced in increment E delta U by T is equal to 1. This means the map of electrical field divergent Mn depends on the thermal to and in particular affected by Ti by Te ratio. To illustrate this effect for different values of Ti 0 by Te, the electrical potential for the plasma jet with an initial non-uniform profile with n is equal to J0 by A0 R by capital R and U theta I is equal to 0, and electrons have a considered isothermal here as it can be in the curvature of asymptotical lines. In the ambipolar, electrical potential decreases monotonically downstreams and outward only. Ti 0 by Te 0 is equal to 0 in any other situation. So minus dou U by dou R points inward initially in the neighborhood of throat to confine the radial expansions of ion, and later downstream minus dou U by dou R points outward again as Ti 0 Te 0 is increased. This strong ending potential jump experimented by the plasma. Thank you.